In the darkness between suns lies a silence older than time itself. An endless ocean of stars stretches outward, each world orbiting its own familiar fire. Within this vast expanse, the solar system is but a fragile island, a delicate eddy. In a cosmic tide that knows no shore, for most of human history, the heavens seemed eternal, the stars were fixed. The planets moved in their ancient rhythm, and the void beyond appeared remote, untouchable, forever separate from the sanctuary of our sun. But the illusion of isolation has shattered. In 2017, the first messenger arrived. A sliver of stone, Oumuamua, raced through our skies on a path no comet of our sun could follow. 2 years later came Borisov, a comet unmistakably foreign, its gases whispering of a birthplace in another star's nursery. These were not of us. They were not born here. They were intruders, carrying with them the echo of other systems. Other histories. And then another. In 2020, astronomers glimpsed something more unsettling. 3IATLA, an object that did not move like the rest, that fractured and flared with unsettling irregularity, as though hiding a story beyond simple rock. An ice. It slipped into our system as though by chance. But chance is fragile, and in the language of the stars, patterns are seldom without cause. What if these wanderers are not accidents of gravity and time, but signals? What if the silence between stars is not silence at all, but a message carried? On the trajectories of strangers, humanity now stands at the shoreline of a greater truth, staring into the abyss of interstellar messengers. Uncertain if they are warnings, relics, or the shadows of an intelligence long departed. In the spring of 2020, the world below was quiet. Cities stood still, borders sealed, and humanity turned inward under the weight of a global pause. Yet above, that silence in the endless dark, the sky remained restless. Every night, automated eyes scanned the heavens, tracing faint lights as they drifted across the void. Among them was a modest yet vigilant sentinel, the Atlas Survey, an early warning system designed to watch for dangers approaching. Earth.Atlas, short for Asteroid Terrestrial Impact Last Alert System, was not built to chase interstellar mysteries. Its task was more urgent, more immediate, to catch the shadows of asteroids hurtling toward our planet, to give humanity days or perhaps weeks of warning before impact. Operating from twin telescopes in Hawaii, it swept the sky each night, gathering fragments of starlight, assembling patterns invisible to the human eye. It was here, in late April of that year, that astronomers noticed something faint, something unusual. A fragile smear of light appeared against the black cometary visitor that would come to be known as C2019Y4, Atlas. At first glance, it seemed ordinary, another comet drifting from the outer reservoirs of our solar system, disturbed from its ancient orbit and falling sunward. But as the weeks passed, a strange story began to unfold. The object brightened rapidly, far more quickly than expected, as though its icy surface were shedding material in sudden torrents. Then, unexpectedly, it fractured, shattering into multiple pieces as though under a stress unseen. Telescopes around the world turned their gaze toward it, recording the eerie disintegration of a celestial body that refused to follow the quiet arc of a normal comet. But hidden within this confusion, another discovery took shape. Calculations of its path revealed something startling. Its orbit was not bound to the sun in the way ordinary comets are. Instead, it traced a trajectory from far beyond the Oort cloud, carrying the unmistakable signature of interstellar origin. This was not just another comet. This was a third interstellar visitor, the next chapter after Oumuamua in 2017 and Borisov in 2019. It was given a new name, 3I Atlas, the third confirmed interstellar object ever witnessed by human eyes. For scientists, the realization carried a weight that was both thrilling and unsettling. Before 2017, no interstellar object had ever been observed entering our solar system. They were thought to be exceedingly rare, their passages separated by centuries or millennia. Yet here, within the span of only 3 years, 3 such objects had appeared. It was as though the sky, long silent, had suddenly begun to speak. At Harvard and at observatories across the world, researchers began to question what they were seeing. Was it coincidence that these visitors were arriving in such rapid succession? Or was it evidence that interstellar space is far more crowded, far more alive with drifting debris than anyone had dared to imagine? The moment of discovery carried echoes of older shifts in human understanding. Just as Galileo's telescope once revealed moons orbiting Jupiter, shattering the idea that Earth was the center of all things, so too did 3-1 Atlas fracture another illusion, that our solar system was isolated, alone, sealed off from the rest of the galaxy. The walls had fallen. The boundary between ours and theirs was no longer secure, and yet there was something stranger. Still, unlike Borisov, which resembled a comet in nearly every sense, or Oumuamua, which baffled scientists with its unusual acceleration and shape, 3-1 Atlas seemed to sit uneasily between categories. Its sudden brightening, its catastrophic fragmentation, and its strange orbital tilt all suggested that this was no simple body of ice and dust. To some, it appeared fragile, unstable, almost as if it had already endured journeys or forces beyond comprehension. When news of its interstellar nature spread, the questions deepened. If such objects are common, how many more pass unseen, too small or too dark to catch? If they are rare, then why do they appear now in such close succession? And most haunting of all, what are they carrying with them across the gulfs of interstellar time? At the moment of its discovery, 3-I Atlas seemed little more than a faint smudge on a digital image. But as its orbit unfolded, scientists realized they were staring at a relic of unimaginable distance, a wanderer that had left its parent star perhaps millions of years ago, only to arrive unannounced at Earth's doorstep. It was a reminder that the solar system is not a closed sanctuary. It is porous. It is vulnerable. It is open to the tides of a galaxy we barely understand, and so, as 3-I Atlas disintegrated under the gaze of telescopes, its fragments drifting silently into the void, a greater mystery remained intact. The object was gone, but its meaning lingered. For in that moment of discovery, humanity was forced to confront a truth both exhilarating and terrifying. We are not alone in the cosmic traffic of worlds. Strangers pass by, and some of them, like Atlas, do not behave as they should. From the moment its orbit was traced, 3-I Atlas revealed a truth impossible to ignore. This object was not one of ours, unlike the comets born from the frozen shell of the Oort cloud remnants of our solar system's birth, circling in the farthest reaches like ghosts. Atlas moved on a hyperbolic trajectory. Its path was not closed, not bound to the gravity of the sun. Instead, its orbit was open-ended, a curve that carried it in from the void and flung it back out again, never to return. To astronomers, the shape of this orbit was the first undeniable sign 3-I Atlas had come from interstellar space. It had been adrift for perhaps millions of years, a fragment detached from some distant system, wandering through the galaxy's dark corridors before intersecting, briefly, with our fragile island of planets. It was not the first such discovery. In 2017, 1I Oumuamua had startled the world with its sudden appearance. A needle-shaped fragment of unknown origin, it accelerated in ways no comet should, slipping past Earth like a messenger refusing to slow. 2 years later, 2I Borisov confirmed what many still doubted: the galaxy is littered with such travelers. Borisov resembled a comet in every sense: its glowing tail, its jets of gas, yet its composition hinted at a chemistry foreign to the solar system, born under a different sun. But with 3-I Atlas, the pattern deepened. For centuries, no interstellar objects had been seen. Then 3 arrived in barely as many years. This statistical unlikelihood sent ripples of unease through the scientific community. Was the solar system drifting through a denser region of galactic space, a swarm of debris invisible until now? Or had humanity simply built telescopes sensitive enough to finally notice what had always been passing by? At Harvard and other centers of research, the questions sharpened. If Atlas came from another star system, then which? Attempts were made to trace its trajectory backward, to follow its path like a cosmic breadcrumb trail. Yet the galaxy is restless. Over millions of years, stars shift, orbits drift, and the original source vanishes into uncertainty. Atlas could have emerged from anywhere, a shattered world orbiting a red dwarf, the icy outskirts of a binary system, or the ruins of a long-vanished planet around a sun that no longer burns. What unsettled scientists most was not only where it came from, but what it seemed to represent. The hyperbolic speed of 3i ATLS, its velocity relative to the sun was not just an astronomical curiosity, it was a statement. No natural body originating within the solar system could achieve such motion. Gravity here binds all things to the sun, as if held in an invisible net. But Atlas moved outside that law. It was a trespasser, obeying a different order, carrying with it the fingerprint of another world. For the first time, astronomers were forced to see the solar system not as an isolated cradle, but as one eddy. Within a wider river, objects could flow between systems. Material could exchange across light years. Even the elements that formed Earth, the carbon, the oxygen, the ion may once have drifted as cosmic debris exchanged between dying stars and newborn worlds. Interstellar objects like a TLAS were not accidents. They were part of a grander circulation, a galactic ecology in which no system is truly separate, yet with this realization came an unease more profound. Because unlike Borisov, which behaved as expected, Atlas defied easy classification. Its sudden brightening and disintegration raised troubling questions. Was it unusually fragile, or had it been weakened long before it reached us? Was this a shard of something older, perhaps artificial, perhaps technological, drifting until the stress of the sun tore it apart? This speculation, whispered on the edge of academic discourse, carried an uncomfortable echo of Oumuamua. When Avi Loeb of Harvard suggested that the first interstellar visitor might have been artificial, a fragment of alien design, he was met with skepticism, even ridicule. But now, with Atlas breaking apart in such an unnatural manner, the question returned with renewed force. How much of what we see is natural and how much is something else? The shock of a TLAS's origin was not just scientific. It was existential. For fragments from other systems are reaching us so frequently, then we are not isolated travelers in a quiet cosmos. We are participants in a larger, more chaotic galaxy where the detritus of other worlds drifts freely, sometimes into our own skies. And if debris can travel between stars, then so too can messages, probes, relics, evidence of civilizations long extinguished or still alive watching in the quiet of observatories as telescopes tracked the object breaking into smaller and smaller pieces. A thought lingered. What if this was not merely a comet? What if it was wreckage? What if it was the dying remnant of something that once moved with purpose? Such questions cannot yet be answered, but they cannot be ignored. The trajectory of 3i Atlas has already told humanity one truth: it does not belong to us. It belongs to a story written beyond our sun, in a language we are only beginning to decipher, and so the shock of its origin was not simply that it came from elsewhere, but that its very presence reminded us of a deeper reality. The solar system is not sealed. The boundaries between stars are not absolute. The galaxy itself is porous, restless, alive with wanderers. And among those wanderers, there may be more than fragments of rock and ice. There may be relics. There may be signals. There may be shadows of other minds. From a distance, comets are simple things. They are frozen relics, icy wanderers that drift silently until the warmth of a star awakens them. As they approach the sun, heat draws vapor from their surfaces, building luminous tails that stretch across space like celestial scars. For centuries, astronomers have studied them, cataloged their behavior, and written the equations that govern their fragile journeys, but 3i ATLAS did not behave like a comet should when first spotted by the Atlas survey. It appeared faint, almost unremarkable. Yet in the weeks that followed, something strange occurred. Instead of brightening gradually as sunlight freed gases from its frozen core, Atlas flared dramatically, its brightness increasing far more than predictions allowed, as though something within it were breaking loose. Then, just as suddenly its light began to fade, telescopes revealed the truth. Atlas was shattering. The visitor from another star was breaking apart into fragments, as if it were fragile beyond reason. By April of 2020, astronomers had confirmed that the object was no longer intact. Its nucleus had fractured into pieces, each tumbling on its own trajectory, dissolving into a diffuse smear of dust. This was not unusual for a comet of our own solar system. Many have broken apart under the stress of solar heating. But with Atlas, the violence seemed disproportionate. It had not yet approached particularly close to the sun, the tidal forces, the radiation, the thermal stress. It should have survived longer. Why then did it disintegrate so easily? The anomaly deepened as scientists studied its orbit. Unlike Borisov, whose path suggested a conventional comet born of distant ice, Atlas carried a tilt and eccentricity that resisted easy explanation. Its trajectory hinted at forces acting on it long before it reached us, as though its long interstellar voyage had weakened it or altered it in ways unseen. The fragments themselves posed more questions. Observations showed uneven shedding of material, bursts of gas and dust that did not follow the symmetrical patterns of normal cometary jets. Some pieces brightened unpredictably, flaring in irregular pulses, as though reflecting light off surfaces that were anything but uniform. For some astronomers, it was as though Atlas carried scars, the marks of an origin story unlike any comet we had known. In academic circles, explanations circulated. Perhaps Atlas was composed of unusually fragile materializes or compounds, unstable under sunlight. Perhaps it had suffered collisions before entering our system, cracks hidden until they tore apart under stress. But there was another possibility, more unsettling, whispered by those willing to look beyond conventional comfort. What if Atlas was not merely a comet? What if it was something older, something broken in object whose very instability was the signature of a different kind of past? For Harvard scientists like Avi Loeb, who had already stirred controversy with bold claims about Oumuamua, Atlas was another reminder that the line between natural and artificial may not be so clear. The fragments of Atlas could represent more than fragile ice. They might be wreckage. Wreckage of something built, once functional, now shattered by the long and hostile journey between stars. Such speculation was not widely embraced. Yet the strangeness of Atlas resisted easy dismissal. Unlike Borisov, it refused to settle into the neat categories of comet science. Unlike Oumuamua, it did not race away intact with its secrets preserved. Instead, it crumbled in plain sight, disintegrating before astronomers could truly understand what it was. It left behind not clarity but ambiguity, an object that seemed to demand an explanation but dissolved before one could be reached. The anomaly of Atlas was not only in its physical form, but in what it represented. For centuries, science has depended on repeatability, the ability to study patterns, to observe phenomena again until certainty emerges. But with interstellar visitors, there is no repeatability. Each arrives unannounced, unique, fleeting, and then vanishes forever. The data is partial, the story incomplete. Atlas, like Oumuamua, left us with only fragments of evidence, each one open to interpretation, each one haunted by uncertainty. This is why its disintegration struck such a profound chord. It was not merely that the object broke apart, it was that its breaking left humanity with more questions than answers. Questions about how fragile or unusual interstellar bodies may be. Questions about what forces act upon them during their million-year voyages. Questions about whether we are truly witnessing natural accidents or whether, hidden within the noise of dust and gas, there lies something else. For, in the end, the anomaly of Atlas was not simply its brightness or its orbit, but the fact that it forced humanity to confront a possibility it is not yet ready to face. The possibility that some of what drifts into our skies is not just geology or chemistry, but memory of other systems, other histories, perhaps even other minds. The fragments of Atlas have long since faded, scattered into dust invisible against the stars. But its meaning lingers. It stands as a reminder that the cosmos does not always present us with familiar shapes or comforting patterns. Sometimes it confronts us with anomalies, objects that resist explanation, dissolve before comprehension, and leave us with only the shadow of a deeper mystery. And that is why Harvard scientists and others around the world found themselves unsettled. Not because Atlas was dangerous, but because it was ambiguous. Because ambiguity is more terrifying than certainty. In the unknown, there is space for fear. Atlas had come from the stars. It broke apart under the light of the sun, and it left behind a silence that no equation has yet filled. Science lives in the tension between certainty and doubt. It thrives on evidence, on patterns that can be tested, repeated, and confirmed. Yet, when evidence is scarce, when only fragments remain, fleeting and incomplete interpretation fractures, and in the case of 3I ATLAS, those fractures became fault lines. In the months following its disintegration, astronomers around the world struggled to decide what they had witnessed. To some, Atlas was nothing more than an unusually fragile comet, natural object, torn apart by stresses common to all icy wanderers, its peculiarities explainable by chemistry and chance. To others, its strangeness fit into a growing pattern of anomalies that refused to stay quiet. The debate split the community into two uneasy camps: the guardians of caution and the explorers of speculation. The conservative view held to the familiar. Comets, after all, are fragile things. Many have been seen to break apart under solar heating. Some crumble without even approaching close to the sun, undone by internal cracks, volatile ices, or tidal stresses. From this perspective, ATLAS's sudden brightening and fragmentation were surprising, but not unprecedented. It was a comet from another star, yes, but still a comet. The galaxy, in this view, is littered with countless such objects born in the outskirts of planetary systems, ejected by gravitational disturbances and left to wander forever, nothing more. Nothing alien, but another voice grew louder, one less willing to dismiss the oddities. Harvard astrophysicist Avi Loeb had already shaken the foundations of astronomy with his provocative interpretation of Oumuamua. Unlike Borisov, Oumuamua had not behaved like a comet at all. It lacked a tail. It accelerated mysteriously, as if pushed by pressure from sunlight. Its shape and reflective properties were unlike any natural body known. To Loeb, the simplest explanation was also the most radical. Oumuamua was artificial, a fragment of alien technology, perhaps a broken sail or probe drifting through interstellar space. His claim ignited controversy. Many dismissed it as speculative, at best reckless at worst. Yet Loeb persisted, arguing that the refusal to consider extraordinary explanations was itself unscientific. If data do not fit the models, then the models must be challenged. With Atlas, the arguments resurfaced. Its disintegration could be explained, yes, but why so fragile? Why so irregular? Why the strange path, the abrupt brightening, the asymmetrical shedding of fragments? For Loeb and others willing to entertain the idea, Atlas might be another relic, not a functioning probe, but wreckage. Perhaps the shattered remains of a structure once intact, drifting for eons until the stress of our sun reduced it to dust. Between these camps, a philosophical divide emerged. Was it safer to assume the ordinary, to cling to natural explanations until no other remained? Or was it more honest to admit that some data defy simplicity, that anomalies may point to possibilities humanity has not yet dared to confront? The debate was not just about Atlas, it was about the framework of science itself. For centuries, the cosmos has revealed its secrets through the steady accumulation of evidence. But with interstellar visitors, there is no accumulation, only singular encounters. Each object is unique, fleeting, irretrievable. Humanity has no laboratory samples, no second chances. The telescope images and spectral readings are all that remain once the visitor vanishes. And from fragments, certainty is elusive. To some, this makes speculation irresponsible. To others, it makes speculation necessary. Within Harvard, within NASA, within the global community of astronomy, the theories divided. The fragile comet hypothesis. Atlas was an interstellar comet composed of unstable ices. Its unusual brightness and sudden disintegration were simply the results of its fragile structure meeting the heat of the sun, the collision hypothesis. Perhaps Atlas had suffered impacts long before reaching us, weakening it until it fractured. Under minimal stress, the exotic ice hypothesis. Some propose that Atlas contained rare materials, hydrogen ice or nitrogen ice, that sublimated rapidly, producing its strange flares of light. The artificial relic hypothesis. And finally, the most controversial of all, that Atlas was not entirely natural, but the broken remains of something once built, long since dead, drifting between stars as technological flotsam. Each theory carried weight, each had flaws. None could be proven. In the wider world, beyond academic journals, the very act of raising the artificial hypothesis stirred public imagination. Headlines whispered of alien probes, of visitors watching silently from the dark. To scientists, this sensationalism was both frustrating and dangerous, threatening to distort careful inquiry into spectacle. Yet beneath the caution, even among skeptics, an unease remained. For Atlas, like Oumuamua before it, had left questions unresolved. And the refusal to ask daring questions does not make the mystery disappear. The divide was not simply scientific, it was existential. To accept that Atlas was ordinary is to preserve a familiar universe governed by predictable rules where humanity remains unremarkable. To consider that Atlas was extraordinary is to open the door to a cosmos alive with histories older than our own, civilizations that may have risen and fallen before the Earth was even born. It is here that fear begins to take shape. Not fear of invasion or of alien machines stalking the solar system, but fear of what the evidence implies. If such objects are artificial, then intelligence in the universe is not hypothetical, it is historical. And if they are natural, then our models of interstellar space are profoundly incomplete, our understanding of cosmic dynamics fragile at best. Either way, the ground beneath certainty shifts, and so the theories remain divided, unresolved, suspended between caution and imagination. Atlas itself has vanished, its fragments scattered, its trail already fading into the silence of interstellar space. All that remains is the data, the debate, and the haunting sense that the truth is larger than either camp is willing to admit. For the story of Atlas is not yet written. It is still unfolding in the instruments, in the arguments, and in the restless curiosity of those who dare to look up and wonder whether the sky has begun to speak in a language we are only beginning to understand. Fear in science is rarely spoken aloud. It does not take the form of superstition or myth, but of silence, long pauses in conference rooms, unease in the way results are presented, hesitation in the eyes of those who know what the numbers imply. In the case of Atlas, fear was not born from the object itself, but from what it symbolized. When scientists looked upon Atlas, they did not see a comet alone. They saw the crumbling edges of certainty. And in that disintegration, they confronted a possibility that unsettled even the most disciplined minds. The fear is layered. At its most immediate, it is the fear of the unknown entering our system. For billions of years, the solar system has been bounded, its story written by the sun and the planets that orbit it. Everything we know, every stone, every particle of dust, every comet from the Oort cloud shares a common origin. But Atlas did not. It came from outside. Its trajectory was interstellar, indifferent to our sun, passing through as though the solar system were nothing more than a roadside flicker. This means our boundaries are porous. The solar system is not a fortress sealed against intrusion. It is open, exposed, and the universe beyond is filled with wanderers we cannot predict, cannot track, cannot stop. The arrival of Atlas was not a singular anomaly. It was proof of principle. Interstellar objects are not rare, they are inevitable. They will come again. Perhaps thousands already passed through unseen, invisible in the black between stars, but fear deepens further. For Atlas carried the memory of Oumuamua, the first object that made scientists hesitate. If one interstellar messenger could defy explanation and another could disintegrate in ways that stretch natural models thin, then what does that mean about the space between stars? Is interstellar space not the silent void we once imagined, but an ocean strewn with debris, natural and otherwise? Could fragments of other histories, even other civilizations, be drifting endlessly, waiting to be glimpsed only once before vanishing forever? The terror is not in the idea of alien technology. It is in the implications of scale. If Atlas is debris, then how many others are out there? How many signals, how many ruins, how many wrecks of civilizations long extinguished are flowing silently? Past our sun? Humanity in this light becomes small, ephemeral, one species on one planet, watching ancient messengers it cannot understand. And then comes the deeper fear still, the one spoken in whispers. What if they are not ruins at all? What if these objects are not dead, but deliberate? Oumuamua accelerated as if under control. ATLAs shattered in ways that seemed irregular, almost mechanical. Could they be probe scouts machines built to drift among the stars, gathering information in ways beyond our comprehension? If so, then they are not relics of the past. They are part of the present. And if the universe is filled with such machines, then silence itself is an illusion. We are already watched. For Harvard scientists and others, this is where speculation turns to dread. Because even if these objects are artificial, they reveal nothing of intent. Are they evidence of benevolence, of civilization seeding knowledge across the cosmos? Or are they grave markers, remnants of catastrophes left adrift like tombstones? In space? Worse still, could they be traps, devices with purposes unfathomable, still waiting in the cold darkness of interstellar night? But even those who reject the artificial hypothesis find reason for unease. The natural explanations themselves are not comforting. If Atlas was made of exotic ices, hydrogen, nitrogen, or even compounds unknown, then our models of planet formation in other systems are incomplete. If countless such fragile bodies drift between stars, then the galaxy is a minefield. Any one of them, if misaligned in trajectory, could one day collide with Earth, unlike comets from our own system, which can sometimes be predicted decades in advance. An interstellar impactor would give little warning. A civilization could vanish not by war or collapse, but by a single dark rock from another star. In this way, the fear of Atlas is double-edged. Either it is ordinary and the galaxy is far more dangerous than we imagined, or it is extraordinary, and the galaxy is far more haunted than we believed. This is why Harvard scientists and others around the world speak of Atlas with such hesitation. It is not the object itself, it is the realization of what its presence represents. That the solar system is not closed, that interstellar visitors are real, that our universe may be filled with wanderers whose stories we cannot yet decipher. The fear is existential, philosophical. It is the recognition that humanity is no longer an isolated observer of the cosmos, but a participant in a larger conversation whose language we do not yet understand. Each visitor that comes reminds us that we are not the center of anything, that we are adrift in a sea of unknowns, fragile in our assumptions, vulnerable in our ignorance. And so the fear lingers, quiet but uncheckable. It whispers not of invasion, but of insignificance, not of danger, but of perspective. For in Atlas, humanity glimpsed the truth of a wider cosmos, a truth that may forever outpace the boundaries of human comprehension. The stars are not silent. The void is not empty. And the next visitor may not be as fragile as ATLAS. Fear in science is rarely spoken aloud. It does not take the form of superstition or myth, but of silence, long pauses in conference rooms, unease in the way results are presented, hesitation in the eyes of those who know what the numbers imply. In the case of 3I ATLAs, fear was not born from the object itself, but from what it symbolized. When scientists looked upon Atlas, they did not see a comet alone. They saw the crumbling edges of certainty. And in that disintegration, they confronted a possibility that unsettled even the most disciplined minds. The fear is layered. At its most immediate, it is the fear of the unknown entering our system. For billions of years, the solar system has been bounded, its story written by the sun and the planets that orbit it. Everything we know, every stone, every particle of dust, every comet from the Oort cloud shares a common origin. But Atlas did not. It came from outside. Its trajectory was interstellar, indifferent to our sun, passing through as though the solar system were nothing more than a roadside flicker, This means our boundaries are porous. The solar system is not a fortress sealed against intrusion. It is open, exposed, and the universe beyond is filled with wanderers we cannot predict, cannot track, cannot stop. The arrival of Atlas was not a singular anomaly. It was proof of principle. Interstellar objects are not rare, they are inevitable. They will come again. Perhaps thousands already passed through unseen, invisible in the black between stars, but fear deepens further. For Atlas carried the memory of Oumuamua, the first object that made scientists hesitate. If one interstellar messenger could defy explanation and another could disintegrate in ways that stretch natural models thin, then what does that mean about the space between stars? Is interstellar space not the silent void we once imagined, but an ocean strewn with debris, natural and otherwise? Could fragments of other histories, even other civilizations, be drifting endlessly, waiting to be glimpsed only once before vanishing forever? The terror is not in the idea of alien technology. It is in the implications of scale. If Atlas is debris, then how many others are out there? How many signals, how many ruins, how many wrecks of civilizations long extinguished are flowing silently past our sun? Humanity in this light becomes small, ephemeral, one species on one planet, watching ancient messengers it cannot understand. And then comes the deeper fear still, the one spoken in whispers. What if they are not ruins at all? What if these objects are not dead, but deliberate? Oumuamua accelerated as if under control. ATLAs shattered in ways that seemed irregular, almost mechanical. Could they be probe scouts machines built to drift among the stars, gathering information in ways beyond our comprehension? If so, then they are not relics of the past. They are part of the present. And if the universe is filled with such machines, then silence itself is an illusion. We are already watched. For Harvard scientists and others, this is where speculation turns to dread. Because even if these objects are artificial, they reveal nothing of intent. Are they evidence of benevolence, of civilization seeding knowledge across the cosmos? Or are they grave markers, remnants of catastrophes left adrift like tombstones in space? Worse still, could they be traps, devices with purposes unfathomable, still waiting in the cold darkness of interstellar night? But even those who reject the artificial hypothesis find reason for unease. The natural explanations themselves are not comforting. If Atlas was made of exotic ices, hydrogen, nitrogen, or even compounds unknown, then our models of planet formation in other systems are incomplete. If countless such fragile bodies drift between stars, then the galaxy is a minefield. Any one of them, if misaligned in trajectory, could one day collide with Earth, unlike comets from our own system, which can sometimes be predicted decades in advance. An interstellar impactor would give little warning. A civilization could vanish not by war or collapse, but by a single dark rock from another star. In this way, the fear of Atlas is double-edged. Either it is ordinary and the galaxy is far more dangerous than we imagined, or it is extraordinary, and the galaxy is far more haunted than we believed. This is why Harvard scientists and others around the world speak of Atlas with such hesitation. It is not the object itself, it is the realization of what its presence represents. That the solar system is not closed, that interstellar visitors are real, that our universe may be filled with wanderers whose stories we cannot yet decipher. The fear is existential, philosophical. It is the recognition that humanity is no longer an isolated observer of the cosmos, but a participant in a larger conversation whose language we do not yet understand. Each visitor that comes reminds us that we are not the center of anything, that we are adrift in a sea of unknowns, fragile in our assumptions, vulnerable in our ignorance. And so the fear lingers, quiet but uncheckable. It whispers not of invasion, but of insignificance, not of danger, but of perspective. For in Atlas, humanity glimpsed the truth of a wider cosmos, a truth that may forever outpace the boundaries of human comprehension. The stars are not silent. The void is not empty. And the next visitor may not be as fragile as ATLAS. If interstellar visitors are the messengers of the unknown, Then Earth scientists have become their interpreter, standing at the shoreline of a cosmic ocean, straining to hear the faintest whispers carried by the tide. The arrival of Oumuamua, Borisov and 3I-ATLAS was not merely a surprise, it was a revelation that demanded a new kind of vigilance. For centuries, comets and asteroids were thought to be local wanderers, bound by the gravity of the sun, but these intruders proved otherwise. They showed that the solar system is not isolated, but open, exposed to currents that flow between stars. To study them, humanity must build instruments not of curiosity alone, but of necessity. And so across mountaintops, deserts, and the vacuum of orbit, a new generation of eyes has been turned outward. The first of these sentinels is the Pan-STARRS Observatory in Hawaii, whose wide-field telescopes first revealed Oumuamua as it slipped through our system in 2017. Pan-STARRS was built to scan for near-Earth asteroids, but in its endless sweeps of the sky, it stumbled upon something larger, the realization that interstellar objects can be caught, if only briefly, by patient and persistent watching. Then came the Atlas survey, also in Hawaii, named the Asteroid Terrestrial Impact Last Alert System. Its mission is simple yet profound: to find threats before they find us. It was Atlas that first glimpsed the faint shimmer of the third interstellar visitor, 3I-ATLAS, in early 2020. Though fragile and fleeting, its detection proved that the system works, that even the briefest messengers can be seen, yet astronomers know this is only the beginning. The universe does not wait, and each object passes quickly, never to return. What is needed is not chance discovery, but a deeper net cast across the skies. This is why so much hope now rests upon the Vera C. Rubin Observatory in Chile. Scheduled to begin its full operations within this decade, Rubin will scan the night sky in unprecedented detail. Its Legacy Survey of Space and Time, LSST, will create a moving portrait of the heavens, revisiting every patch of sky again and again, mapping not only stars and galaxies but the subtle trails of objects in motion. For the first time, humanity will have a systematic way to catch interstellar intruders in real time. Where Pan-STARRS and Atlas caught 3, Rubin may catch dozens or even hundreds. Beyond Earth, new instruments are already watching. The James Webb Space Telescope, with its ability to read the faintest heat and light, offers the possibility of studying the composition of such visitors in exquisite detail. Though Webb has yet to target an interstellar object, scientists know that the next one could provide a chance of fleeting opportunity to look directly at the chemistry of another star system. Plans are even more ambitious still. NASA has begun to consider missions capable of intercepting interstellar objects directly, spacecraft launched in readiness, waiting like arrows in a quiver, able to chase down the next messenger before it vanishes. One such idea, the Interstellar probe, would not wait for discovery, but fly outward on a trajectory designed to meet these objects as they enter. In such an encounter, instruments could measure not just the light reflected from afar, but the very dust, gas, and fragments of another system. The European Space Agency, too, has spoken of missions that could one day pursue an interstellar traveler. And private research groups, from Harvard's Galileo project to independent think tanks, are building tools not only to detect, but to interpret, to ask whether the anomalies we see could truly be natural or whether they hint at something more deliberate. In these projects lies a deeper truth. Humanity is no longer content to wait passively for answers. The scientific fear born of Oumuamua and Atlas has transformed into resolve. To study the next visitor is not merely an act of science, it is an act of survival and of meaning. Yet the challenge is immense. These objects arrive with little warning, traveling faster than any probe humanity has ever launched. To intercept one requires foresight, coordination, and technologies that stretch the limits of what is possible. The window of opportunity is brief, sometimes only weeks from detection to disappearance. The cosmos offers no second chances, and so the night sky is now treated differently. Every flicker is examined, every trajectory traced. Astronomers around the world have formed rapid response networks, able to turn telescopes within hours to focus on a new discovery. Satellites, spectrometers, and ground-based observatories share data across borders. Because the mystery of these messengers belongs to no single nation, it belongs to all of humanity. Still, even with this vigilance, the greatest challenge remains interpretation. Light curves, spectra, and orbital models can only say so much. To know what an interstellar object truly is, one must touch it, study it directly in the vacuum of its journey. Until then, scientists work with shadows, with fragments of data translated into theories, but shadows can still speak. And in the silence of those shadows, science has found its purpose renewed. For each detection is more than a discovery, it is a reminder that we are not alone in the universe of matter, that other systems shed their fragments into the dark, and that in those fragments lie the secrets of creation itself. This is why the search continues. Not because interstellar objects threaten us, though they might. Not because they may reveal other civilizations, though they could, but because they are the only tangible threads that tie us to the stars beyond. Each detection is a fleeting handshake across the void. Each measurement, a glimpse into the infinite diversity of worlds we will never see. And in those glimpses lies not only science, but hope that the universe is not distant and unreachable, but flowing through us, brushing against our sun, leaving traces for us to find. With every telescope lifted to the sky, with every mission planned, humanity is preparing. Not for war, not for conquest, but for recognition. The recognition that the solar system is not a closed story, but a single chapter in a narrative far larger. And when the next visitor comes, as it surely will, we may finally be ready to listen.